continue here. Investigating current in a wire. Last thing we said, resistance can be changed by changing the amount of the resistance in the current wire. How can we change the amount of the resistance in a current wire? To understand it well, let's imagine that we have a runners or many runners, not one, many. Okay, they want to run through a narrow road. Okay, let's imagine that there's buildings and so these runners can't go side by side, they can go one each time. Okay, if we want to make it fair for them, we will make it a wider road, so this one can step and come here next to this one. So increasing these things, which is the cross-sectional area of the wire. We use thin wire or wire with large cross-sectional area. Here only one electron can pass, here many electrons can pass. So here we are increasing the current, and increasing the current is related to decreasing the resistance. Okay, so if we increase the cross-sectional area of the wire, we can increase the current and decrease the resistance. Also, if we make the wire shorter, instead for these runners to go all the way from here to here, okay, in this way, like this, okay, we can make it shorter for them. We can make it straight road, straight for them. So shorter wire will have less resistance. Okay, so wider wire will have less resistance, shorter wire will have what? It will have less resistance. Now let's go to the investigation written here. Plan an investigation to find out how change the length of the wire in the circuit in figure 9.22 affect the current. What will you change and what will you measure? The thing that we will change is called the independent variable, because we are changing, and in this case it is the length of the wire. And what you will measure, we are going to measure the current. Okay, so why? Because we are investigating the current. So here we have a meter to measure what? To measure the current. So we are going to change the length of the used wire, okay, which is here, which is fixed on the ruler, okay, and measure the current that comes with that length. Wires can get hot when current flows. Why it can get hot? Hot is heat energy produced by friction, and this friction is the friction between small electrons when we get high resistance. Okay, you must write a risk assessment. A risk assessment, it is the extra heat energy from the wire. Okay, this should explain any risk and how you will make sure you do the experiment safely. So in order to avoid wire melting or what is called short, we have to open the circuit as soon as we get the readings. So I'm taking the ammeter reading, then we will off the circuit. Okay, write your prediction. Well, our prediction will be, as I said before, if we increase the length, the resistance will increase, so the current will be less. Okay, do your experiment and record and measure in a table. So we have to record actually the independent variable, the thing we are changing in column 1, and independent variable in column 2. Draw a graph of your result with length of the wire on the horizontal axis and the current on the vertical axis. Describe the relationship, as we said before, it will be a inverse relation, because as we increase the length, the resistance will decrease. Thank you.